Okay, yay. Chapter 16.2, I'm doing it a little bit differently. I'm using your printed version, and I'm showing you the teacher's version. There's a reason for that, but anyhow, we're proving figures are similar, and go ahead and copy down the essential question, you avid students. How can similarity transformations be used to show two figures are similar? Okay, so you can go through all this stuff, but basically, similar means you have the same shape, but different size. Oh, does that sound familiar? Yep, yesterday we learned about dilations. And pretty much when you want to say that two shapes are similar to each other, we know that there's dilation going on. So it's the same shape, but sizes are different, okay? So one thing you have to remember about similarity is that, of course, the lengths are different, but angle measures are the same. Okay, so you have to go through different steps. As you can see, you have the patio, you have blah blah blah. So basically, you have to go from here. I mean, EFGH over here, and then you have to go ahead and make sure that this goes over there. And so the way you did it, you had to like do a rotation. And I'm showing you the answer. This is the teacher's addition. Okay. And I'm doing this on purpose. I wanna show you the answer, okay? So there you go. Here's a reflection, and there you go, blah, blah, blah. And then over here, you have to determine if figures are similar or not. And we talked about this in class, but let me just mention it one more time. Dilation means you gotta multiply by a number k, as you can see over here, to both the x and the y. And k is the scale factor. Okay, so in class we talked about we have a small triangle, we got a big triangle, and we were talking about how the scale factor is 1 to 2. Actually, we went from a big triangle to a small one, so it was 1/2. But anyway, the k would be, in our class situation, 1/2. Okay, so, and then we talked about if the shape goes from big to small, we have to multiply by what number? A number smaller than 1 but still bigger than 0. So it had to be like a fraction, 1 over 2, 1 over 3, 4 over 5, some kind of fraction less than 1. It could be decimals too, like 0.8, 0.9, but it has to be bigger than 0 and smaller than 1. And that's when you're going from big to small. But when you're going from small to big, what you're going to do is you're going to multiply by a number bigger than 1. This is so important that I'm talking about this for 2 days in a row, okay? So these questions are quite self-explanatory. You can go ahead and work on it on your own. And so basically, you're trying to figure out like how do you have to move the initial shape. Over here, you don't have to worry about regular letters and letters with prime on it because it just tells you. Are they similar? And they tell you LMNO and GHJK. So you're going to basically just start with the first one. That's the question pretty much. So you're going to use this one first, and then you're going to try and map it onto this one. And yes, I'm giving you the answer. The red is the answer to your turn question. So I'm going to keep moving on because a lot of the things that we are learning here, you really can't do it online. You have to actually do it with me in the classroom, unfortunately. And let's just go ahead and take a look at this question over here. Okay. In order for two figures to be similar, there has to be some sequence of similarity transformation that maps one figure to another. So, you know, there has to be more than one. So, for example, ABDC to EFHE. So you already know that this is the pre-image, okay? Because it says this to that, and you know that this is the image, right? So this big shape is gonna map onto the small one. So then you already know that there has to be a dilation in between 0 and 1 because there's a difference of size, right? This one has to go there. And so the dilation factor must be what? In between 0 and 1. And then the length of AB is 1, 2, 3, 4. And what's the length of this one? 1, 2. It looks like 2, right? So then it's probably 1/2. So you put all your coordinates, right? Original coordinates. A is where? At 1, 6. B is where? At 5, 6. So you find all these points, right? and then you divide everything by 2. And so then these are, the reason why I'm using this version and not the interactive version is because I saw a lot of mistakes in there, so I'm using this one instead. Okay, so once you shrink it into half, you figure out that, now your new points are going to be where? Half, comma, 3. 1, 2, 3, there you go, and that's A prime. And then you're going to have B prime, which is 2.5, comma 3. There you go. C prime at negative 1, comma 1. And then you have D prime at 1, comma 1. So then when you actually draw it after the dilation of 1/2, you know that still this red shape does not match onto this one over here. You still have to move it, okay? So then your next step is what? You gotta move to the right by 1, 2, 3. Actually, you gotta move to the, my bad. So you have to start from this point and get there. So I gotta move to the right by 1, 2, and I have to go down by 1, 2, 3. Am I right? Yes, I'm right. Because it was in the middle. So it's like 1, 2, and then 1, 2, 3. All right? And so there you go. It says right 2 units and down 3 units. And if you move it, all that way for all the other points, it would totally go on top of this, right? And that's how you know that these two shapes are similar to each other, because after you shrunk this, you had to move it, and it was exactly the two shapes mapped onto each other. Okay, so as you can see, this is something that's very difficult for you to understand online, which is why we gotta do it in class. So when you come to class, I'm going to skip all of this stuff. Actually, we're already done. And I'm going to give you a printout of the evaluate section using the print version, which would be this page right here. And I'm going to give you this page and the next page. And so what I'm going to do is I'm going to scroll down really slowly, because these are the questions that we're going to work on in class, but I'm giving you the answer. Okay? Because I know sometimes you're studying because you want to get that A, and then you get frustrated because you can't find the answer. Okay? So again, I'm going to give this printout to you tomorrow, this page right here. So I'm scrolling down really slow so you can see the answer. Okay? And of course, you're going to pause it if you want to. And there you go. So these are all the answers. Let me scroll down some more, because I'm going to give you these 2 pages, that one and this one right here. This is the next question. We're going to, of course, use this graph to, map it onto each other. But here's the answer. No, they are not similar. Let's take a look at number 5 and 6. These are the ones where you gotta like shrink them, move them, reflect them, right? So over here it says first you can map this triangle into that by a reflection. First you gotta reflect it, and then you gotta translate it, right? So it tells you the rules over here, okay? These are all your answers. So go ahead and take a look at it, and then we're going to go ahead and work on it in the classroom tomorrow. And so that's it for today. I just want you to remember a few things, okay? Just remember that in order for us to say that two shapes are congruent, okay? In order for us to say that two shapes are congruent, they need to have the same size, same shape, and we can only use rigid transformation. And what rigid transformation means is you can either translate, which is just moving it, or you can rotate, you know what rotating is, or you can go ahead and reflect. And that's about it. But if you want to say that two triangles or any kind of shape are similar, okay, then just it's still the same shape, but it's a different size, okay? And so when we talk about same shape, different size, obviously we think about dilation. Then again, we have to think about what? Non-rigid transformation. Non-rigid transformation is the same thing. It's another word for saying, it's the same shape but different size. Okay? And so that's it. And also always remember, from which shape are we starting to go to which shape? And how many times do we have to move? Not only do we have dilations, but we have to dilate first, and then we gotta reflect, rotate, translate. So you have to find out all those different movements that happens, and we're gonna work on that in class. So I hope you had a great time learning today. I'll see you in class tomorrow. Goodbye.